Hey guys, and welcome back to another video. Today we will be going over the rest of the circle theorems that we have been talking about for the past two other videos about finding missing angles in a circle. And each of them, they're all circle theorems where we have the theorem that we're able to find the missing angles because of the certain things that gives us the answer of the missing angle. So I'm going to go over four more that I have not discussed yet. And these ones are very simple, so we can get this one right away and very quickly in like one video. So the first one is where a quadrilateral is inside a circle. So let's draw that. Again, a quadrilateral doesn't have to be a square. It just needs to be four sides, a circle. And because it is a quadrilateral inside the circle, the opposite angles would equal to 180. Would equal together 180. So opposite angles means this and this. So let's say we call this A, B, C, D. The points where the vertexes or edges of the quadrilateral touch the circle, or the circumference of the circle. And so angle A plus angle C would equal to 180. So we can write it, angle A plus angle C would equal 180. And so same goes with B and D. So that is the theorem for quadrilaterals in a circle. Moving on to the next one. The next one is the theorem that a triangle lies on the semicircle line. So if we're drawing a triangle here, which lies on the line of the semicircle of the circle, so it lies on the diameter. It is what I also mean. So yeah, that's more of the correct term. But technically the triangle is only on half of the circle. Yes, but the triangle is on the diameter, which makes the angle here 90 degrees. So any triangle that lies on the diameter and that is like on half the circle only, on one side of the diameter, is a right triangle. So we can do any, like we could draw another circle here and then a diameter line. The triangle can be anywhere, and you can really see that it's 90 degrees anywhere. And in the middle, it's also 90 degrees. So it's because two of the points of the triangle has to be here and here. So it makes it 90 degrees and a right triangle. The next one is a theorem that all the angles that are on the same segment would be equal. So the segments inside of the circle. So the theorem where angles that are in the same segment would be equal. So let's draw a segment right here. We can draw a segment here. It could be, so it's probably a chord. This is kind of like the semicircle in a triangle theorem, but it doesn't have to be the diameter. And so if we draw two triangles here, we can draw one here, and then we can draw another one here. The angles here would be the same because they come from the same segment. They share same segment that is on the circle. So it would be the same. It wouldn't equal 90, but they would be congruent. So maybe this is Z and this is Y. Angle Z would be congruent to angle Y. We don't know the measurement because this is not a diameter, but it's the chord that they share. So those two angles are equal. The next theorem is involving a tangent. So let's draw one. Tangent here. And remember, a tangent only meets the circle at one spot. I know it looks like it kind of looks like it touches this whole entire bottom, but it only touches one spot. So we can say right there. And so the theorem is that if the radius and tangent touch, so let's draw one, then that means that the angle where the tangent meets the radius would be 90 degrees. So then this would be 90 degrees because this is where the tangent and radius meet, and because the tangent only touches at one spot and the radius meets the tangent at that one spot, it would be 90 degrees because like the tangent like kind of touches it only at one spot. Yeah, that's really the reason, I think. And so this theorem involves two tangents. So two tangents that would start from the same point. So that means they would congruent tangents because they start from the same point. Because again, a tangent can only touch a circle at one position. So that means there's only one possibility, one direction the line of the tangent would be able to go. Because we can't say it goes like this because it's gonna touch the circle more than one time. So because we have to touch the point here and the point on the circle one time. I know my drawing's probably not correct, but yeah, it's technically touching. So then we would conclude that these tangents are equal. They have to be equal because they have to touch the circle at one spot, and it will only allow them to touch at one spot. That would be the same on both sides because they come from the same point. So tangents from the same point are equal in length. And so those are all of the rest of the circle theorems that I did not go over. And that is basically the rest on like kind of missing angles. Technically, this one is not missing angles, but we can also say that when there is just a line drawn from the radius to the point over here, or the point to the radius, then these two angles would be congruent since it's kind of splitting the main angle in half of the tangent. So yeah, so those are the circle theorems, and thank you for watching.